Welcome back. We are continuing our way through Chapter 6, Addition, and today we discuss 6b, Addition Properties. There are 4 properties of addition that I will talk about. So first of all, let's assume that A, B, and C are whole numbers. No fractions, no decimals, just whole numbers, 0, 1, 2, 3, and on. The first property that addition of whole numbers has is called the closure property. If A and B are whole numbers, then A plus B is a whole number. 2 is a whole number, 7 is a whole number, 2 plus 7 is 9, 9 is a whole number. Whole numbers are closed under addition, but if I think about subtraction, subtraction is an example where whole numbers are not closed. If I took 2 minus 7, I would not get a whole number, it would be negative. But regarding addition with whole numbers, addition of whole numbers is closed. Addition is commutative. A plus B equals B plus A. 2 plus 7 equals 7 plus 2. I can change the order of addition and it won't change the answer. Addition with whole numbers is associative. Associative means that I keep my 3 numbers in the same order, A, B, C, but I change the association, I change the grouping. Let's say I have 2 plus 5 plus 8. And 2 plus 5 plus 8. On the one hand, I might group the first 2 together and get 7 plus 8, which is 15. Or I might associate the second 2 together, in which case I get 2 plus 13, and I still get 15. It doesn't matter how I associate the terms, the answer will be the same. And once again, I want to emphasize I'm not changing the order. A, B, C, A, B, C. The order stays the same, but the grouping just changes. Our last property is the identity property. This means that there exists a very special whole number, 0, with the property that A plus 0 is 0 plus A. Well, that's not special, that's commutative, that works for everything. But what's important with 0 is that we just get A in return. 0 is called the additive identity. Here are some equations, and we want to know what property is being used. Why are these equations true? So look at this first one. What have I changed, and which property does it use? It looks like 10 plus 12, 12 plus 10. That was switched around. Well, that's true because of the commutative property, so that equality is true. Now, let's say that this second equation is equal to another one. What has changed here? There's been a regrouping. Previously I had 3 plus 7, well that stays the same, and the 12 and the 10, but now the 12 is grouped with the 3 plus 7. So the order of the elements has stayed the same, but there's just regrouping. We have an equality, and this is due to the associative property. Okay, moving on, another equation. What is going on here? Why is this equality true? It looks like the 3 plus 7 and the 12 have changed places. So that is the commutative property. Another one. What has changed here? It looks like the order, I had plus 10 at the end and now the 10 comes in the beginning. This whole group in brackets has just moved. There's no regrouping, just change of order, so that's commutative. One more. It looks like regrouping has occurred here, so that's the associative property. All right, let's move on. What property are we using here? If you want to add 101 plus 36, you probably know that the answer is immediately 137. You don't really go through the addition algorithm, 101, 36, 137. You probably, in your head, think to yourself, well, this 101 is really the same as 100 plus 1, and then I need to add 36. And 100 is nice and even. We'll just leave it out there. I'll add the 1 plus 36 to get 37, and then my answer is 137. What you've really done is you've taken this 101 and you see it as a group, 100 plus 1. Then you regroup the 1 and the 36 to make 37. So you're using the associative property without really even thinking about it. Lastly, let me talk about closure. Which of these sets are closed under addition? So the first set, all even numbers, 2, 4, 6, 8, 10. If I take any two even numbers and add them together, I get another even number. So in fact, that set is closed under addition. What about the second example, all the odd numbers? Well, the odd numbers are not closed under addition. If I take two odd numbers, for example, maybe 1 and 3, 1 plus 3 equals 4, but 4 isn't in my set. So this set is not closed under addition. Pause the video now, take a look at the last three sets, and see if you can determine yes or no whether they are closed. And then when you're ready, start the video again. All right, I've assumed you've paused and made your choices. Let's see. 3, 5, no, not closed. I am allowed to take the same number twice, and so if I get 5 plus 5, that's 10, and 10 is not in the set. Set 4, all the whole numbers 49 or bigger? Yes. If I take any two whole numbers that are 49 or bigger, I'll get another number that is 49 or bigger. And then set number 5, is it closed? No, there's a few things I could do. For example, I could take 1 plus 1 and get 2. Or maybe I could take 1 plus 7 and get 8. In either case, there's a couple examples that show us the set is not closed. All right, those are the basics of addition properties. So give the homework a try and let me know if you have questions. Thanks.